Hi guys, I trust that you're feeling well and awesome. Welcome to this video on grade 10 mathematics, and this is going to be the first in a series of videos covering the concept of factorization. In this video, we'll have a look at the common factor. So, we'll have a look at what the common factor really is, or what is factorization in general, why do we use it, how do we do it, and then eventually we'll get into the main concept of the video, which is going to be the common factor. So without any further ado, let's get straight into it. So factorization is defined as the process of finding the factors of a given expression. Now you would remember from grade 9 that we said factors are numbers that divide exactly into another number without leaving a remainder. And so what we want to do here is we've got an expression, we want to find out what the factors of that specific expression are. Now, the method of determining the products or the factors depend on the type of equation or the type of expression which we have. Now, there's different methods of factorizing. There's the common factor, which we're going to be having a look at in this video. We've got the difference of two squares. We've got the sum or difference of two cubes. We've got grouping. We've got trinomial. My hope is to cover all of these by the end of this specific playlist. So we'll have more and more videos covering each of these individually. But now let's have a look at the concept for today, which is the common factor. Now you would remember that a factor, as we said, is a number that can divide exactly into another number without leaving a remainder. So if we do have two numbers dividing, or let's say for example, we've got A divided by B. Now if B goes into A and we leave a remainder, then we cannot say B is a factor of A. So if we get A divided by B is equals to C and there's no remainder, it means that both B and C are factors of A. So this is something that you learned in grade 8 and 9. So this is just a revision of exactly what a factor is. Now, if you look at the example here, we've got 16. We say 2 is a factor of 16 because check this. 16 divided by 2, this is going to give us 8. What is our remainder? Our remainder is 0. Because we have a remainder of 0, we can say that 8 is a factor of 16. Now, 3 is not a factor of 16, because check this. If I say 16 divided by 3, I will get something like 5, comma. The fact that there's a comma and there's a number after the comma, I believe this is 5,333 recurring. The fact that we have a number after the comma means that this is not a factor. So in other words, we are saying that 16 divided by 3 is going to give us 5 with a remainder of 1. Because the remainder is not 0, 3 is not a factor of 16. I hope that this makes sense. The common factor is the same factor of two or more terms in an expression. So basically, what are we saying here? When we are asked to find a common factor, we must have a minimum of 2 terms and a maximum of any number of terms for that matter. So, how do we factorize a common factor? Well, the first thing we need to do is we need to identify the highest common factor. I'm sure you still have memories of grade 10 on how to, grade 9. You've got memories from grade 9 on how to do this when working with numbers. And then secondly, you need to write the highest common factor outside a set of brackets. Next, you need to divide each term in the expression by the highest common factor. The answer to each of these terms you have to write inside of the brackets. What you can do is, notice I said this is optional here. You can multiply out the highest common factor with every term in the bracket just to check if your answers are correct. So after multiplying out, if it gives you the original expression, your answer is correct. If you're not getting the original expression, it means you did something wrong. Please take note though, this is optional. It is not compulsory for you to do this in your working. It's just meant for you to check it out. Okay, let's see, how do we find the highest common factor of variables? So in grade 9, we learned how to find the highest common factor of numbers. So for example, if they ask you what is the highest common factor of 16 and 8, we know that factors of 16 would be 1, 2, 4, 8, and 16 itself. If they ask you to find factors of 8, you will have 1, 2, 4, and 8. Now, your highest common factor, your highest common factor in this instance, you would see that we've got 8 there, we've got 8 there. Since 8 is present in both, your highest common factor would be 8. So we need to also take note of the fact that you'll be asked to find your HCF in terms of variables. To find the highest common factor of variables, you need to identify which variables is or are common. So do you have x in every expression? If you do, x is going to be part of the highest common factor. If we have k in every expression, k is going to be part of the highest common factor. Now, if the common variable has exponents, we need to take the lowest exponent as part of the highest common factor. Please take note of this. If it's not making sense right now, we'll have a look at an example shortly to demonstrate what this means. When dividing the highest common factor with the same variables, we need to subtract the exponents. Now, you probably remember this from laws of exponents that you did in grade 9 and that you're still going to do in grade 10. But when you divide numbers of the same base, we subtract the exponents. Let's have a look at an example of how we would do all of this. So here's our first question. We've got 2xy minus y. Let's go over to the writing pad and let's do this. So the question says we've got 2xy minus y. Now what we need to check here is what is our highest common factor. When looking at our coefficients, we've got 2 and negative 1. The highest common factor of our coefficients in this instance would just be 1. Now looking at our variables, the first term has x, but the second term does not have x. So x does not form part of the highest common factor. But now look at this. Our second term, in the same instance, from the first term we've got y, the second term we've got y. So because we've got y in both terms, y will form part of our highest common factor. And therefore our highest common factor is going to be 1y, or as you learned that any number with an coefficient of 1 could just be written as the number itself or the term itself. So what do we then do? We write our common factor there and we introduce a set of brackets. Now, we take the first term, which is 2xy, and we divide it by y, our common factor. Now, if you take a look at this, the y's will cancel out, you just remain with 2x. Therefore, we are going to put 2x inside of the brackets. Next, we have to say negative y divided by y, that's the second term divided by our common factor. This is going to give us negative 1. So we can put the negative 1 back there. We are done finding the common factor. We are done factorizing it. Now we said we could multiply out this. And if you don't know how to multiply out such an expression, please check out our video on products. I'm going to leave the link in the description. But yeah, we can have a look at the video on products so that you can see how we multiply this out. And basically, if we have a setup like this, we take the number outside the bracket, multiply by the first number inside the bracket. So 2x times y, that's going to give me, 2xy. Then I'm going to say y times negative 1, and that's going to give me negative y. My expression here is exactly the same as my original expression, therefore my factorization is correct. Once again, as I've mentioned in the notes, it is optional for you to do this. It's not a must for you to do it. It's just to check if your answer is correct. So I'm going to get rid of this. It is not necessary for this particular example. It is not necessary for our answer. Our working stops, that's a terrible line. Our working stops right here. Wonderful. Life is great. So let's have a look at the second example. We've got x cubed plus xy squared. So let's look at this one. We have got x cubed plus xy squared. Now let me erase the working that I had for the previous question just so that I can have enough room and that it doesn't confuse what we are doing. Okay, now looking at this scenario, we need to check. Is there a common variable? Or first, let's check our coefficients. The coefficient of the first term is 1. The coefficient of the second term is 1. So in my highest common factor, the highest common factor between 1 and 1 is just 1. Now let's check the variables. I've got x cubed in my first expression. I've got x in my second expression. This is x to the power 1. Now, we said in the notes, whenever we've got a common variable with different exponents, we take the lowest exponent as part of the highest common factor. So always remember, lowest exponent forms part of highest common factor. In this case, 1 is smaller than 3, so I'm going to have x to the power 1, which is x, being part of my highest common factor. Now, as we've learned, if a number has a coefficient of 1, we don't need to write the coefficient. If a number has an exponent of 1, we don't need to write the exponent. So our highest common factor is going to be x. Let's put x outside of the brackets. And now we need to say, take the first term divided by the divided by the highest common factor. X cubed divided by x, we said when we have such a scenario, we need to subtract the exponents. We get x squared. So I'm going to put x squared there. Next, let's take the second term, which is xy, and we divide it by our common factor. The x's will cancel out, you just remain with y. So we are going to have positive y there. Wonderful. Life is great. We are done here. I hope that this makes sense to you guys. I hope you're enjoying this content and that you're finding it useful. If you are, please subscribe to the channel. Please give us a thumbs up. Click on the notification icon so that you'll never miss an update. You'll always receive a notification when we upload new videos. All right, let's move on to the next question. So in our next question, we've got 5a cubed plus 20a plus 15. So let's have a look at this. We are saying we've got 5a cubed plus, what was the question again? 5a cubed plus 20a plus 15. So 20a plus 15. Okay. Now, once again, what I'm going to do is I'm going to remove the working from the previous question so that we don't confuse anyone with what we're doing and we don't mix up our work. There we go. So, how do we then factorize this? We need to check, do we have a common factor? Well, let's start with the coefficients. We've got 5 and 20 and 15. Our highest common factor in this instance is just going to be 5. Let's look at the variables. We've got a cubed, we've got a, and then we have no variable. Now, because the variable a is not present in all of the terms, I'm not going to take it as a part of my highest common factor. I only take the variables or the variable which is present in every term in the expression. So my highest common factor is just going to be 5. Let's scroll down for some room. So I put my highest common factor and then I introduce the brackets. Next, I take the first term, which is 5a cubed, divided by my highest common factor. This will just give me a cubed. All right, let's put a cubed there. Next, I take the second term, which is 20a, divided by my highest common factor of 5, and this is going to give me just 4a. There we are. Let's add the 4a there. Lastly, I take the last term, which is 15, and I divide it by my highest common factor. This is going to give me 3. So let's put the positive 3 there, and we have answered the question. Brilliant. Life is great. Let's look at the next question. We've got negative x squared plus 4x squared. So let's look at this one. We've got negative x squared plus 4x squared. Now, let me erase the working from the previous question. We don't need this anymore. Thank you very much. You've been very helpful, but you gotta go. Okay, looking at this question that we're on now, we need to check our coefficients. We've got negative 1 and we've got 4. Now, my highest common factor in this case is I can take out positive 1 or I can take negative 1. Let me take negative 1. Now, looking at the variables, I've got x squared in both of them. So x squared will be part of my highest common factor. In effect, I can write this as negative x squared. So let me put my common factor, which is negative x squared. Let me introduce a bracket. Now, we take the first term and divide it by the highest common factor. Whoops. Oh yes, this is correct. So negative x squared divided by negative x squared, that's just going to give me positive 1. So I put positive 1 there. Next, I will say, okay, let me take 4x squared divided by negative x squared. And this is going to give me the x squared and the x squared cancel out. I remain with negative 4. So let me go ahead and put the negative 4 in brackets. Now, when you have an expression like this, 1 minus 4 can actually be simplified. So I could put negative x squared, and then 1 minus 4, that gives me 3. You can multiply this out and you get negative 3x squared. In fact, what I could have done is, from the get-go, I could have identified that we've got like terms here. And because we've got like terms, remember, like terms can be added and subtracted. What are like terms? These are terms with the same variable that have the same exponents. So I could have just said straight off of the bat, negative 1 plus 4, that gives me, whoops, I noticed I made a little bit of a mistake. This is supposed to be negative 3. Then negative times negative gives us the positive 3x squared, right? So I could have said straight off of the bat, negative 1 plus 4 gives us positive 3x squared, because we've got like terms. Awesome. I hope that this makes sense. Now you might be asking, in the same question that we did just now, what if we took, let's say for instance, let's say this did not exist. So let's get rid of what we did here. And you would remember I said to you, when finding the highest common factor, we could use negative 1x squared, or we could just take positive x squared. So we could have just taken positive x squared. Let's see what we were going to have if we took positive x squared. Now I'm going to do it right next to the working I have here, and I'm going to use a different color. Let's see, a blue looks like a good color. So right next to this, I'm going to put my highest common factor of x squared. Then I'm going to say the first term divided by my highest common factor will give me negative 1. So let me go and put negative 1 right there. Next step is, let's take the second term divided by our highest common factor. X squared and x squared cancels, we remain with 4. So let's come back here and let's put plus 4. You will see that I will get x squared into negative 1 plus 4 gives me positive 3, which will still give me 3x squared. So in either case, whether I took out negative 1 or I took out positive 1 as part of my highest common factor, I would still get the same answer. Wonderful. Life is great. Let's look at the next question. So here's an interesting one. 8a squared b squared minus 64ab. Let's write this down. So we have got 8a squared b squared minus 64ab. So once again, let's identify what our highest common factor is. In our coefficients, we've got 8, we've got 64. This is negative 64. Our highest common factor in this instance is going to be positive 8. Now looking at the variables, there's a in both of the expressions, but we've got a squared in a. Which one do we take? The one with the lowest exponent. So that's just a. Looking at the b, we've got b squared in b. Which one do we take? The one with the lowest exponent. So our highest common factor is 8ab. Let's write this. 8ab. We open a bracket. Now we say, okay, the first term, which is 8a squared b squared, divided by our highest common factor. The 8 and the 8 will cancel. I will remain with a to the power 2 minus 1, b to the power 2 minus 1. This will just give me ab. So let me go ahead and put ab there. Next, I look at the second term. Negative 64 AB divided by 8AB. So AB and AB will cancel out. Negative 64 divided by 8 will give you negative 8. So I could just put negative 8 there. And we are done. Life is great. So let's look at the last question. Oh, this one is interesting. A plus c squared plus a plus c to the power 5. I like this one. So we have got a plus c all squared plus a plus c to the power 5. So first of all, let's erase everything we were doing so that we do not confuse our working. Life is great, life is great, life is great. All right. So in this instance, our highest common factor, looking at the coefficients, we've got a coefficient of 1 and a coefficient of 1, so I don't need to worry about that. But just for the sake of brevity, let me add the 1. Now we've got a plus c squared and a plus c to the power 5. A plus c and a plus c. The lowest exponent between these two is the 2. So my highest common factor is going to be the a plus c squared. This is just going to be a plus c squared. So let me write it out here. I've got a plus c squared. I open a bracket. That's a terrible bracket. Better. So now we say the first term, which is a plus c squared divided by our highest common factor of a plus c squared. This is going to give me 1. So I put in the 1. Next, I say the second term, which is a plus c to the power 5 divided by a plus c to the power 2. We are dividing numbers of the same base, we subtract the exponents. So a plus c to the power 5 minus 2 will give me a plus c to the power 3. So I am going to put here plus a plus c to the power 3, close the bracket. And there we are done factorizing it. I hope this video was informative. I hope it was productive. I hope you guys enjoyed the content. If you have any comments, please do let us know in the comment section. Otherwise, please like the video, subscribe to the channel, click on the bell icon so that you always receive an update and a notification when we upload new videos. Most importantly, please share this video with others so that everybody can benefit from the knowledge that we are learning here. Until the next time we see each other, well, the next time you see me, or well, you at least get to see the video, please enjoy the rest of the day. Have a wonderful one. Ciao.